Hi, everybody. Thank you for coming to my talk. My name is Tim. That's my GitHub and Twitter and probably everything else, every other form of social media or developer account handle. I'm a quantitative developer at Cubis Systematic Strategies, which is a global quantitative hedge fund, and I teach in the computer science department at Columbia. The slides for this talk are at this link. I don't know. They're also on my GitHub, so you can find them there. I've given this talk a few times. It's got some good updates for recent developments. Basically, we'll spend a little bit of time talking about background, motivation. The talk is called, high performance data visualization for the web. So try and go into some of the problems that motivated the tools that we have since built. Talk about perspective, which is this library that we wrote. WebAssembly, C++, Python, JavaScript, Rust, kind of grab bag of whatever we needed to get the job done. And then I'll do some live coding maybe, kind of cheat with the live coding. I usually have already written all the code, and then I'll just kind of walk through it. But everyone who's ever given a live demo know that that's to avoid any embarrassing errors. And I'll do some demo stuff, and I will maybe write a little bit of code or tweak a couple of things just to get the point across. Cool. So the background of this talk is that there's a lot of web frameworks. If you're here and it's a Python conference, you know about some of them, I'm sure. There are a lot of them. I love Fast API. It's a great one. It's probably my go-to these days. Flask, kind of the original, like OG, popular one. Tornado, Sanic, Django. There's way more than just these, but just to list a few. And it's not really a JavaScript conference. If you're kind of data-oriented Python person, you know about many of the kind of data visualization components available to you, whether in kind of pure Python land, matplotlib, stuff like that, or in the kind of JavaScript space, D3, things of that nature. So despite there being a ton of web frameworks and a ton of JavaScript frameworks, a ton of data visualization frameworks, some things that you often want to do are still quite difficult or clunky. And I tried to break these down into kind of three main areas that maybe you've seen before, maybe you haven't, where, even though we have this wealth of tools, stuff is still really difficult to do. So the main pain points, I think, are virtualization. I think this one's becoming more and more relevant as data gets larger and larger. But basically, this is a picture from my Airflow server, where I have, I guess, 728 passing tasks or something of that nature. The DAG passed 728 times. And this is how I could browse through, all of those different runs. So thankfully they were passing. But if they were failing or failing for different reasons, virtualization would be this ability to have something like an infinite scroll, or to be able to present all of the data in one form, to be able to do operations on potentially unbounded data sizes, as opposed to what we usually do, which is some form of kind of pagination. So it's good in certain contexts. It's annoying in others. Many web frameworks either can't or won't support like unbounded data sizes. So a lot of times when you Google how do I do how do I serve a bunch of data out of a Fast API server, you'll get some documents on kind of pagination and things of that nature. But when your data gets large or unbounded, and unbounded might seem unrealistic, but for streaming data, you never really know how big it's going to be. This is a problem. So second big problem I think that you face is that even though it's 2024 and we've had computers for a pretty long time, it's kind of difficult to get a good grid, like a data grid. Maybe you can find a grid that's got some filtering and some sorting, and there's some beautiful ones. I'm a huge fan of libraries like Great Tables. But an interactive kind of JavaScript-based grid that you don't have to pay for, with maybe some filtering, maybe some sorting, maybe some Spark charts, like the little charts that you can embed in columns of the grid themselves. Maybe, it's usually a big maybe, some type of pivoting, some form of aggregation. You basically have like two options, despite having so many different JavaScript libraries, so many different Python libraries. So here's an example of an option. You can kind of see that it's a difficult problem. There's a lot of UI problems, a lot of user experience issues that you can face, but you kind of want to have this ability to pivot in some form, perform some aggregations of the pivoted data. There's some filtering at the top. some row pivots, some column pivots, all the stuff you would want to do in a pandas pivot table, just presented in a kind of UI form. So they're not always great. Even when you can find a great grid, now wonderful, you've presented your data in grid form. You've got all this fantastic pivoting, but now you want to show it in a heat map or a tree map or bars, and you have to go and ask ChatGPT to generate a bunch more D3 code so that you can plug it in, so that you don't have to learn JavaScript. It's kind of difficult to do these things. It's annoying. So you also end up with, a lot of times, I mean, I definitely do this when I build my UIs, some form of visualization explosion, and not to be mean to different apps, but you end up building stuff that looks like this, where because you just have a grid component, or maybe you just have a bar chart component, you end up having to slice and dice and present your data in 100 different ways, just to kind of capture all those nuances, all the different ways of looking at it. I think, I don't know if I have a Grafana one here, but this is, kind of the canonical example of like just showing a bunch of data in a bunch of ways. I think this is mostly for us as people who write these applications. It's not really so much for the people who use them, maybe. It's like kind of showing off in some form or another. But a lot of times, this is too information dense. You're kind of losing a lot of stuff, and you still don't present your end user the ability to explore stuff on their own. And the last one, if you've ever done anything with streaming data, it's still not great. There are some emerging tools to make this easier. On the Python side, there are more and more kind of stream processing frameworks, or more and better stream processing frameworks emerging. On the UI side, again, a lot of times you ask ChatGPT, give me the code for this. It'll give you something that's completely static. You won't have this ability to update data in place, kind of accumulate additional data points. A lot of times, again, if you look for tutorials, you'll get something like, poll for new data and do some form of pagination. Well, that doesn't really work super well when you have streaming data, especially where things can be overwritten or reordered. A lot of times I've tried a couple, I'm not going to name them because I don't want to insult any tools, but I was looking at one API recently and it was doing pagination as data was updating. So you'd get a page of data, it would ask you, it would give you the kind of ID for the next page, but in between when you first queried and when you next queried, the data could change and the pages would be off. It's like, kind of defeats the purpose of doing pagination in the first place. And yeah, the web frameworks, visualization frameworks, they don't really make this easy. This is the, let's see if I can click on it. And again, I love Fast API, so this is not an insult. But this is the WebSocket code from the Fast API docs. And it's, like kind of a decent amount of code. I think this is a kind of shared messaging server. A decent amount of code to do something that's basically like, have somebody open a UI, send a message in, and broadcast it to all the clients. So you still don't get any of the issues of like, what if I've already seen this data before? What if I'm reconnecting? Some of these problems of like, do you want to kind of snapshot and then do offsets? And at the same time, like imagine now you're not just presenting flat data, but you want to present aggregated data in some form. So you're pivoting by some column and doing aggregations and then streaming updates in, and you want all of those pivots for all of your users to be, correct first of all, but also updating in real time without having your server have to do all these n different aggregations. So these are like some of the problems that we were facing when we went to build this library. And build it, I guess we sort of did. It's not, work in progress. I think every open source library is a work in progress. But we built this library called Perspective. And this is like the description from the GitHub. Interactive analytics data visualization component, which is especially well suited for large and or streaming data sets. So if you have the slides link, let me get out of full screen because I can't navigate here. You'll see the GitHub homepage. It's Finos. github.com/Finos /perspective. So we've got some docs here, examples, stuff you can look through. A bunch of different kind of pre-canned. Oh, you can see prior talks too. Pre-canned examples. This is the documentation page. You can see a little bit of exhibition of what it can do. And I'm going to go through some real code to show you what it can do. But basically, it's a streaming pivoting data engine. Yes, another kind of pivoting, I'm not going to call it a data frame library because it's not, but another pivoting data engine, something, not quite a database, not with the kind of resiliency guarantees of any database, but not a data frame library either. It's written mostly in C++, though the C++ code base is decreasing day by day. We bind to Python in the backend, and we bind to JS in the front end via WebAssembly. So you have the same C++ code base, same types of, the exact same calculations or aggregation implementations on the back end. If you're using the Python side of things, you've got just a kind of pure server interface, or on the front end in WebAssembly if you're just using the JavaScript side. And then there are like visualization UI plugins in Rust and TypeScript. And a lot of stuff is moving to Rust just because it's a lot easier with such a kind of wide set of targets to do things in Rust. So basically, yep, symmetric C++ engine, GIL-free processing. So trying to make it as performant as possible, make sure that as streaming updates are being applied, we could, for example, send those to all of the available clients without having to grab the GIL for each one potentially. We have this client and client-server architectures. I know there's some other talks about WebAssembly. I think there's one. I don't think it's right now. It might be right now. But I think there's one later in the day about some of the emerging kind of WebAssembly stuff. It's really great for these types of, potentially client-only, meaning just the browser, but also maybe you want to have a server. Maybe your data doesn't fit in the browser. Not having to kind of rewrite your entire code base, being able to reuse critical portions by just compiling in the front end to WebAssembly or compiling to native platform in the back end. Makes it super convenient. And we use Apache Arrow pretty heavily. So all of this, virtualization that I talked about earlier, where, you want to be able to send the next bundle of rows as the user is scrolling, or potentially a user has updated a row, or in the back end a row has been updated. You want to kind of provide that diff very quickly. We use Apache Arrow for that. Okay, on the front end, WebAssembly, web components and WASM. So we have this perspective web component with WebAssembly running underneath, and plugins for different views. So you've got data grid, you've got bars, you've got tree map, heat map, sunburst. Making this where the user can configure what they want to look at, and they can actually toggle it. So it's not just a UI component, but it's also controls components where they can adjust what they're looking at. Okay, cool. Was that all the... Oh, there's more. Okay, fine. Show me the code. Yeah, so there's a bunch of, again, at the slides, all the code I'm showing today you can go and look at, but also in the examples, we have a ton of things. So real quickly, there's a bunch of examples on the website. So I know like this one you can see in real time, kind of pivoted grid. It's probably a little bit small for folks in the back. Apologies. This is the same type of thing where you've got a data set. You're able to control things here. So I'm probably going to make nonsensical pivots because I can't really see it on the screen, but you can kind of do these different types of aggregations. It's all, this one actually is entirely within the browser, so there's no server here. The data's all been brought into this kind of WebAssembly-based engine. You can do kind of nice things. This is the same data set. I think it's Olympic medals by sport and country. You can do things like cross-filtering, right? So I can kind of cross-filter down and have all of my views adjust. And this is a static data set, but you can do the same thing with real-time data sets. So this is a IMDb movie data set. This is a kind of fake market simulator one. Again, I'm looking at one of the available plugins, which is a heat map, but I could also look in kind of data grid form. It's a little sparse, so not super interesting, but you can see rows updating down below. This is a fun one. I don't know if it's going to work. This is a vanity one that we do for talks and presentations and stuff, but I think this is should use my camera. Hi, that's me. And same deal, you have the different, I think the spreadsheet is a little bit weird, but you can look at the kind of heat map version. It's a little bit more, there I am, a little bit better to look at. I think there's some other interesting ones. So same deal, just by changing the kind of plugins that you're using, you can let the user present or let the user explore their own data. All right, so I'm going to use a little stream processing library, kind of shameless, I guess, self-promotion inside of some self-promotion. We've been working a lot on kind of making the streaming side of things better in addition to making the visualization side of things better. So my current company, we've open sourced a library called CSP. There's a talk, there's an upcoming talk. There was a PyData London talk about it. I think there might be a PyData NYC talk about it. But it's github.com/point72/CSP. This is not what this talk is about. I just needed a really solid stream processing library for me to do some of the live demo on. One nice thing about perspective, in addition to kind of performance and flexibility, you've got a lot of developer-focused tools. So there's a Jupyter plugin. I'm just very quickly going to kind of simulate a data set of a bunch of machines that have different types. They're in different regions. They have different sizes. I've got some kind of fake data generators here that can generate usage information about CPU, memory, stuff that you might care about, kind of telemetry, monitoring stuff. I can generate fake jobs and stuff like that. And I'm just going to plug this into perspective. So I'm using this CSP library to just plug it into some of these UI components, just so we can get a sense for like how it can perform, what it looks like, what the user can see. So here I'm just going to make a couple of these widgets, lay them out. I can't see that well, but hopefully you guys can see better than I can. And we can kind of tick things through, and you can see things are streaming into these. I've got a data grid presentation of these things. I can potentially do pivots. If I update some of the views for these things, here's me just turning it into a bar view, where I can do an aggregation in real time. This time I'm aggregating by status, I guess. I don't remember exactly what that means, and I'm kind of counting the number of machines and showing that in a bar form. I can do the same thing with a simple web server. And again, all of those pain points of dealing with offsets and updates and the new client joins, make sure they get the right data, make sure the pivot is being presented to everyone consistently. That's all handled, so I didn't need to have any extra code for that. Here I do a little fast API code, mount a directory for some static files, plug in the Perspective WebSocket handler. We provide ones for Tornado, Fast API, and AIO HTTP, I think. But it's pretty easy to roll your own if you need. Here's that same data, just generating some fake machine metrics, and then plugging it into these Perspective tables. All right, and again, all that bridge between the Perspective engine and the UI itself, you don't have to write any of that code. It's all provided for you. And then the front end, also pretty straightforward. Because of web components, I can basically load the JavaScript assets and then just kind of have a Perspective viewer, right? So we have this custom component. You can give it an ID, whatever. You can give it styling and stuff like that. And then I can just connect to that WebSocket that's been hosted, and I can just load that table into those Perspective components. So let me do this now. Just run it. I won't show you the terminal side, but I just started it. I'm not cheating that much. And close that. Let's pop over to this. So here is, again, same type of data. I made it run a little slower because I want there to be a surprise. Right, so we've got these different viewers being presented. I can do all that pivoting and stuff in real time, so I can pivot by kind if I want. Do some aggregations. I can pick what aggregations I want to do. I can say, I don't know, standard deviation of cores. That doesn't make a ton of sense, but you just get a sense for that. You can do these calculations in real time, and furthermore, you can set it up for the user, but the user can also go and explore it themselves. Because it said high performance data visualization, let's make that actually true. So I have this updating every second. Let's make it update every 0.1 seconds. And let's see how that looks. Oops. All right, so moving a little bit faster again. I can do all of these pivoting and stuff that I want to do in real time at this faster speed. Great. This is a static data set, so it's not going to update. So that one was boring, but let's do this one. Group by kind here. All right, again, all happening in real time. This is happening on the server side, but I could also have this set up to just run in the browser. And I said high performance, so let's make it even faster. This is where the vanity picture comes in. You got to have a vanity picture. All right, so I can have this thing be, again, updating in real time, doing these aggregations in real time. I can do even more complicated aggregations. This one has custom Spark bars here. So these are derived columns with expressions that are being evaluated in Python or in C++. Here's a tree map version of it. So I'm, again, doing aggregations. I forget exactly what this one is, but we're pivoting by kind, region, and zone. We're sizing by the number of cores. We're coloring by the CPU usage. Again, all of this stuff is happening in real time with just the code that I showed you a second ago. And we get a bunch of nice things for free, like cross-filtering. Here I can kind of filter down by, the type of machine, an edge machine, a worker machine. Here I can filter down by region. Oh, I just broke my computer. Oh. Maybe a little too fast. Overly ambitious for this talk. That's all right. Right, and again, the user's able to go in and explore things on their own if they want. If they want to go and pivot things, takes a little bit of getting used to, but once you know what you're doing, you can start to do your own aggregations. So rather than as a developer having to build your own, build every single UI that the end user wants to see, you can kind of present them some nice default views and let them go and explore on their own. Cool. Oh, did I get rid of my talk? I think I did get rid of my talk. Let me just bring up the, it just says Q&A. But again, it's on github.com/finos/perspective. I will just pop it up. Yeah, cool. I think that's everything. Oh, I'm getting the sign that I have to end anyway. So any questions, feel free to ask. Otherwise, we've got the GitHub, the docs, everything you can find through the link to the talk, or from my personal GitHub, or from the Perspective GitHub. Cool. Thank you.
Thank you, team. Has anyone questions? Yes.
Hi, thank you very much for your presentation. It's very interesting. I think you can filter your grids through other grids, as you've seen,
Yeah.
as you've shown us, through Workspace, if I recall correctly. I know there is an API in JavaScript to do that. Do you plan on adding it directly to the Python interface for users to define Workspace through Python code?
Yes, so actually it's been a pretty interesting development. I don't know, it sounds like you're somewhat familiar with, yeah. So we originally had the C++ code base, and we had a Python and a JavaScript implementation of these user-facing features. But I just migrated the talk, and as a project, we just released a version 3 where we've taken all of that kind of separate JavaScript and Python code base, and we've moved it into Rust. So you're starting to be able to do more of this configurability in Rust. And again, there's some other WebAssembly talks, which I think people should go to. This has been really fruitful because it becomes so much easier to build shared experiences and also these kind of scalable things where you can take something that right now only runs in the front end and push it back into the server without having to completely re-implement. So not everything is yet possible to do in the Python side, but that's basically where we're going. And the kind of Rust, PyO3 on the Python side, WebAssembly on the front end side is enabling us to do that.
Okay, thank you.
Thank you for the presentation. I didn't know the library. It seems very interesting. I already thinking of use case for this. In that regard, I would like to ask you about the maturity of this project. If this production ready for like thousands of users at least, and also is it going to break if I feed it a lot of data and it lives in the JavaScript side? Should I do that in the server? What are the best practices for that?
Yes, so a couple of separate things. So we built this, and I know we're kind of mixed audience, but we originally wrote it at a bank, which for some of you is a good thing, and for some of you is a bad thing. But it's quite a mature project. It's still being developed a lot. One of the main authors has a startup now, which I should plug, but I didn't put a slide in here. Kind of built around this, going after things like Tableau or Looker, kind of building these more user-focused data exploratory experiences. So it's fairly mature. I have used it in production at a bunch of different places. I think it's kind of definitely usable. I think there's a question of how much you want to show to do you expect your users to be exploring or not be exploring? You're just kind of presenting views. That might dictate if you need like a tutorial or something like that to help them. On the other side, your second question was how big can it get? Like how reliable?
No, the data.
Yeah, so it's not a big data visualization tool. It doesn't do some of the, like HoloViz does a lot of cool like downsampling stuff. We don't do any of that, and we're not a database. So generally speaking, your architecture would be something like you have data living somewhere. And again, this new development of the Rust API layer is letting us kind of divorce ourselves from our own data engine. So very shortly, we have a DuckDB kind of pilot where instead of using the Perspective engine, you can just plug it into DuckDB and use DuckDB as the kind of data engine and perspective as the front end and kind of interactivity side. I would say that the general architecture is having your data stored wherever your data is stored, kind of pulling it into perspective in a way where if the server went down or if you had n copies of the server, it doesn't affect your underlying data. As far as the pure JavaScript side, you're bounded by what the browser can do in WebAssembly, which is single-digit gigs. There's a little bit of a kind of not great user experience that sometimes creates where you're downloading it. In the client-server mode, there's no bound. It's basically whatever you can fit in memory, but it is in-memory data engine. So if it's out of memory, Perspective can't do it yet, but in kind of version 3+, that's what we're targeting, being able to connect it to a different backend store directly.
So one last question.
Impressive talk that gives a strong impression of reliability. Congratulations. I have a question about the visualization that you showed us. According to you, what would be the difference in terms of user what they would expect? Between basically a tech person and a C-level person. How would you adapt to that? Because you mentioned some startup coming off and stuff like that. So I would like to have your opinion on that.
Yeah, so I think a lot of places, I don't want to say it's like an old school opinion, but a lot of times in tech organizations I've worked in, it's like, okay, the end user can't do anything, right? So build something exactly for them. And in finance, it happens a lot as well, where it's like, can I have a couple of pixels shifted or something like that? And you're like, all right, let me go re-implement that and represent it to you. And I think that turned out to be somewhat of a misguided viewpoint because you see it a lot with like ChatGPT and stuff. People are very keen to use stuff and they're very keen to learn things. And I think you can talk about the success of tools like Tableau and Looker as being, business users want to be able to dive into things. Like they've had Excel forever and they do unbelievable, sometimes scary, but usually pretty impressive things with Excel. Like why are we afraid to give them their own data visualization tools? Now, you don't necessarily want to give them D3 and say, hey, have at it, see what you can do. But giving them the ability to say, hey, you can pivot things here. Giving them an experience that is similar to tools that they know, in this case, Excel-style experiences, has been super successable in my experience. And I think a lot of people, when they play around with give your business user like I don't know, like a little DSL or something like that. Let them type commands and you'll be impressed usually with how many problems they're able to solve for themselves rather than coming back to their tech team and having them do it.
Thank you, team. Can we have a round of applause for team again?